Hello, welcome back. Let's look at a little introduction, if you like, dive into machine learning. So, if you look at the name, it's artificial intelligence. So, we assume that it is only humans that are intelligent, or if you like, mammals that are intelligent, not machines. So, if we are trying to make machines intelligent, we call it, and because the machine is not a human being, the only way that I'm intelligent is if you feed the machine with data and you write an algorithm for the machine to learn from the data you have fed. Then the algorithm can ask some decisions to be taken based on the data. So without data, there's no algorithm or there's no machine learning. And all of that falls under the broad field of artificial intelligence. And if you look at it, really, that's how everything we do is based on information that we have. How you are programmed, your social orientation, the schools you go to, the people you hang around, the materials you read, the materials you consume. That's how you make decisions. So for us to do any form of machine learning, we need to feed data into an algorithm and let the algorithm learn from the data so that we can use it for decision making. And as we go along, the decision making, we can read the model and improve it by way of optimization. Now, in doing that, there are basically the basic tools are two. So, where you are learning from a response variable in order to make decisions based on other variables that are influencing the response, or where the data is structured and labeled. So if you have a typical data that's both structured and labeled, then what we call is that it is called supervised machine learning, supervised. So it's like your typical regression equation that you know. So you have a dependent variable and independent variable. And that's because you have the structure of the data, the variables are labeled. So when you have that, you have a supervised machine learning. But if you don't have, you only have the data, you don't have the structure, you don't know the labels, then you can do what they call unsupervised machine learning. So you don't need a dependent variable or independent variable. So you just need the data and you can attempt to find patterns in the data. Those are the two main aspects of it. But if you go deeper, reinforcement learning both come under either supervised or unsupervised. So reinforcement learning is basically improving the model continuously based on trial and error. So you don't build the model and leave it. You let the model interact with the environment and agents for continuous improvement. And for deep learning, when you have a complex model, complex relationship that you want to model, you will use set of neural networks, just as the neurons in our brains work. It's a complicated network of various neurons. So you can have a multi-layer machine learning algorithm to make decisions. So that's deep learning. And all of them can be used for several things. The basic things that machine learning tools are used for is what we call classification. So grouping agents, items, data into different specific characteristics. You can do that with either supervised learning or supervised machine learning. If you take a typical logistic regression, somebody asked about dependent variable or categorical data regression when we were doing the regression the last time. So we realized that we can have a dependent variable that is categorical. So it's either this or that. It is binary or has several levels of distinct nature. Now, when you have that in a typical regression, you cannot use the OLS as we did. You have to resort to what we call the logistic regression. So if that's the case, you realize that we are categorizing between this or that. You can do the same in machine learning where your dependent variable is categorical and it can make that regression. With that, when it comes to machine learning, you don't have to get a specific regression model. You can use the same regression that you use for continuous data for categorical data as well. So for classification. You can also talk about decision trees. So that's also another form of classification when you have a lot of branches or categories. Now with the with the classification by regression in machine learning, there's an algorithm which is used, which is called a support vector machine. So if you have a support vector machine, it can implement support vector regressions for you. Unsupervised learning can also do classifications, and we will look at examples of where classifications happen in everyday life. So, what are the uses of machine learning? For that, prediction. One of the earliest use of machine learning or artificial intelligence was Google's prediction of is it flu trends? Flu trends. They started, I think, in 2008 and they ended it in 2015. So they were predicting the next outbreak of flu in the US based on how people are searching for GPs based on flu drugs, definitions of flu, symptoms of flu, all those searches that are related to flu based on where they are coming from the US. They can use their IP address and locate where the next flu outbreak is. That's a typical machine learning algorithm. And if you also heard, there was a big news when Walmart, most of you may have heard of Walmart in the US, there was a man who took Walmart to court because they were sending emails to his daughter. And the emails were advertising pregnancy or mother care products. So the man was furious because why would they send that to his teenage girl? It turns out that the girl was pregnant, but the man did not know. So they were basically recommending items to buy related to the search items that the girl has done. And you may have seen those in your email. You search for a school or you search for an item, the next thing is all over your page. If you have bought things from Amazon before, they keep sending you recommendations. It's all machine learning, artificial intelligence. So those are recommender systems. They can also be used to detect change in behavior. And one key area that's used is fraud detection. Because your banking or financial behavior is known by the financial institution. So if there's a very stark difference in what you do, they will flag the transaction and probe further. And you can use it for looking at changes in price and demand, all of that. As also, we can look at loan default, success and failure of marketing campaigns, all of that. So machine learning is all over the place. We are mostly going according to machine learning recommendations without us knowing. So maybe you can also think of a time where you can be building machine learning tools to also influence other decisions. If you look at ChatGPT and all these generative predictive models, they are machine learning and AI algorithms, which have learned from huge sums of text data over a long period of time. So when you go to ChatGPT or you go to Llama or Meta and you put a search there, the results is going to come from a long data of information that has been trained, that the model has trained on for them to generate the results for you. So how does a typical machine learning algorithm works? There's the data and you have to train the data. So normally you divide the data into two. In some cases, they divide it into three. They have the test, the training set, the test set, and the validation test, which is for validation purposes, but it's not usually done. unless you get in the typical validation stage. So you have your data, your big data, not your big data in the sense of big data, but your large data set. You divide it into two so that you train your model on the test set, on the training set, then you are going to test the model on the test set. So normally it's about two tests against one test. So you train the data on two tests. So you should train the data on the larger side and test on the smaller side, maybe 80%, 20%, depending on the specific situation. So whatever your algorithm is, you apply it to the training data. And when you finish, you can implement or check the quality on the test set. And then you can make predictions. All the other examples of predictions that we talked about, you can do. So we want to look at a typical one example of supervised machine learning, and it's called the support vector machine, in which we can form regressions on. A few things about that: it is nonlinear, it is non-parametric, and it is high dimensional. So those are the advantages. Now, why is it high dimensional? Remember, we are going to split the data into two, training and test. So each test data point, each training data point has its own dimensions. And the test set has its own dimensions. And if you are going to evaluate the model with a test set against a training set, that is also another dimension. And you can use different distributional assumptions. In this case, you will use what we call kernel because we are talking about non-parametric. We call them kernels, and different kernels can be used. And what is very important is that it applies very well to categorical data. So I'm giving just a brief mathematical background of the support vector. It's a regression. So you typically have a dependent variable portion, and it's also the structure, the data. So you're going to have your typical dependent variable side and your independent variable side. And in that case, there's going to be an error term. And because of the nature of the kernel, the error term has different conditions as compared to the OLS that we know. So what are the conditions? So the condition is that you want the error term to be minimized, but minimized in what sense? It should deviate from y. So in this case, yn is the function of fx by an amount that is not greater than the error term for each training point. And at the same time, it should be as flat as possible. So if this is in a vector, it doesn't have to be, it's not going to be a linear relationship. It's going to be something like x, let's say x, y, and z, and you can have plot which can be of any shape. So what you want is that if it's a cone, you want the cone to be as flat as possible. That is minimized. So you minimize the error term through a particular situation, and you use the optimization algorithm for this convex function of the error term. And if you look at this side, it's a simplification of what the minimization works. So for all values, so this is the mathematical science for all values for yn minus the xb plus b, and you realize that is this one, but that is the dependent variable. That's the same thing we did for OLS. The error term should be less than a particular value, and it should be flat in addition to that. If that condition is met, is satisfied, then you are going to have a support vector regression that is good for your data classification. So that's just a brief idea of how it works. This is a high dimensional data situation. Now, before you work with your data, you need to pre-process it. That's very important. The first thing is to look at by cleaning the data, especially with NAs. So if your data is large or you have NAs that are a lot, you don't want to remove all of them. You may reduce the data. So what you may do is go through what you call imputation process. So you may do an interpolation and put the mean of the two values that are around the missing value. So you can do that. I'll show you how that one is done. So you can clean by imputation. Then, of course, you should split the data into your training and test sets. So that's the next thing. The next thing is that you want to do feature scaling, or what you call standardization. So that's very important, because if you have this, I'll show you briefly. Let me take data that is, so you have two, let's say your Y data is in the form of this size, and then your X data is in the form of this size. If you make a regression between these variables or these objects, the relationship will be misleading. So what you need to do is standardize them, or what you do, we call feature scaling. So what is going to happen is that it's going to move them as close as possible. Maybe this one will come to this side, and maybe this one will come to this side. And that will help you to match the regression better. So you can do that by using the standardization, the centering that we did when we were doing descriptive statistics, or you can do any of the transformations. A lot of the packages have inbuilt methods to do the scaling. So you have to do that. Then you have to code your categorical data as well. So even in regular regressions in Excel, you can code your categorical data. Is it a yes or a no? Maybe you want to use 0 for yes and no for 1. It doesn't matter. If you have more than 2 categories, you can name them 1, 2, 3, or 4, however many they are, because the algorithm is a numerical algorithm. So it will not be able to work with characters. So you need to convert the categories into numbers. That is categorical coding, or some call it encoding. So that's one. That's the processes that you use. Once you have cleaned the data, or you have fully pre-processed the data, then you can fit the data into your algorithm.